so much to the PSSN program for supporting this work, not only financially, but also in putting on events like this, which are a wonderful opportunity to help develop these ideas and get some feedback to challenge us to our ideas further. And thank you also to my mentors, Daphna, Shohamy, Sajda, and George Lewis for supporting this work and also challenging me to see these ideas from new perspectives. Okay, a neuroscience of improvisation. How would you do that? Well, one way you could do it is you could invite musicians to come to the laboratory and to scan them in an fMRI scanner. And you say, in this condition, please improvise. And in that condition, please play from memory. And then you record brain differences and you see which areas of the brain are more active in one condition than another. And whatever brain areas are more active, you attribute those differences to what it is that you thought distinguished improvisation from rehearsed performance in the first place. So for instance, maybe you thought that improvisation was different because when you're improvising, you're playing something new, something novel, or something spontaneous. And so any brain difference that you find, you would presume, has something to do with novelty and spontaneity. But maybe not. I mean, if you weren't clear on what improvisation was in the first place and what you were asking them to do in the first place, it's problematic to map the brain data onto that kind of initially unsound premise of what you think it is that they're doing. I take this to be a problem. I think it's problematic to characterize improvisation as novel and spontaneous. It's not always that way. There's kinds of improvisation. There's a lot of variety here. In short, it's important to have a critical understanding of the practice in order to start an empirical research program. It goes both ways. This is a complicated and subtle issue. But basically, what I'm trying to do, as Pamela mentioned, is to... Oh, sorry. That's right. Thanks. Okay. What I'm trying to do, as Pamela mentioned, is to develop a definition, a theorization, a conception of improvisation that is both critically informed and compatible with neuroscientific methods and theories as a component of explaining what it means to improvise and how people do it. I go about this by considering improvisation as a way of knowing. Not all musicians are the same. Different musicians may know about similar musical structures, like chords and scales, in different ways. They know them in different ways. They know similar things in different ways. They go, why is this the case? They learn differently, they practice differently, they come from different traditions. They might be able to talk about F minor 7 chords, but the way that they've experienced them, the way that they practice them, the way that they know may be different. And I see the challenge here is to describe in more detail how those ways of knowing differ and why certain ways of knowing, particular ways of knowing, underlie or enable the ability to do what we normatively call improvising. That's what I take to be the challenge. I think that phrasing the question that way makes this question compatible with neuroscientific theories and methods. You can go about exploring that question in that way, among other ways. Well, what might this be? I mean, here are some hypotheses. Maybe it has something to do with perception-action coupling. Improvisers often practice skills like imitation and transcription. They hear something, they learn how to play it, they know which movements are associated with which sounds. This is something that is not as often practiced by classical players who don't improvise. So here's a potential difference. I did an experiment on this last year. I am not going to focus on it today. I'm going to be talking about the second thing today, which has to do with perceiving function. Maybe there's some difference in the way that improvisers and non-improvisers perceive function, and I'll explain what I mean by that in a moment. Just to briefly say, there are clearly other ways that you could describe differences in ways of knowing, and I intentionally frame the question broadly. There are lots of ways that you could describe that. I'm focusing on, so far in my research on two, but I do intend that there could be many ways, not just neuroscientific and psychological ways, to describe different ways of knowing that could contribute to this conception and definition of improvisation. Okay, what do I mean by perceiving function? If you consider by analogy a chef who's following a recipe that calls for lemon juice, but they don't have any lemon juice, but they have lime juice. These images are not to scale, by the way. And so they make the substitution to lime juice. Now, how are they able to do that? It in part hinges on their ability to recognize the function of the lemon juice in the recipe. That is that it's acidic, or perhaps that it's citrus. And the chef has some knowledge of that. They know that these are functionally similar. They can make the substitution in some cases, maybe not in other cases. For instance, if it was lemon juice because he needed something from something yellow, I don't know. But there would be some dimension.
You could also imagine a chef who was following a recipe that called for lemon juice. They don't have any lemon juice, and so they either don't make the recipe or they go out and they get some lemon juice. Maybe it's because they don't realize, maybe they're a novice chef and they don't realize that they could have used anything else that was acidic or citrus. They just don't know that. Or maybe they come from a tradition where you just don't do that. Either way, they don't have experience with this kind of a thing. Two chefs, they know about recipes, but they know different things about the ingredients. I think something is also true like this in music. On the left, you can kind of see a lead sheet, typical of what a jazz player might use. And on the right, you can see a fully notated score, typical of what a classical player who typically wouldn't improvise would use. On the left, you can see that there are chord symbols here. There's a red button. Yes. You can see here, this is an F minor 7 chord. Now, if a jazz player sees this, they can play many different possible things when they see the F minor 7 symbol. They could play an F, A flat, C, and E flat. Or they could play an A flat, C, E flat, and F, change the order of the notes. Actually, there's many, many possible things they can do in changing the voicings. For the musically inclined among you, I'm thinking also of things like tritone substitutions. You can actually change the chord as long as it performs the same function. Jazz players are very used to doing this, something that this is how they read, this is how they understand, this is how they know about musical structures. Whereas, on the right, when you can see the classical musician, there's a chord there in the left hand of this piano part. And if you were playing this piece, you would play these 3 notes, and those are the 3 notes that you would play. And it's not to say that there isn't another chord out there that might serve a similar function in this musical context. You just wouldn't do that. You wouldn't have experience doing that. You wouldn't know about the chord in that way. If I phrase the question in this way, this kind of a thing can be adapted into a cognitive scientific experiment. I've designed an oddball task to probe this difference, working with groups of improvisers and non-improvisers. Let me play for you what they hear in this task. And the task is to identify the deviant chord progressions. Now, each chord progression is going to change key, so the difference that I'm talking about is not the key, it's something else. I'll play it, and I'll point out where the differences are. Maybe you can tell, too. There's one. There's another one. Okay, maybe you heard those. Maybe the musically minded among you also heard that those 2 differences were different kinds of differences. Okay? So there's a standard, that's the one that you're normally hearing. And then sometimes there's what I call an exemplar. Maybe you also could tell because of the slide, I don't know. But there's something that I call the exemplar deviant. That's a different exemplar of the same chord, but it has the same function. It's a different chord, I mean, acoustically speaking, but it has a similar function. There's also a functional deviant, which is where the chord is different, but it's also a functional difference. So in the task, the question is whether one is more salient than the other, basically, which could tell us something about the organization of people's knowledge of these chord progressions. Just a quick note about the stimuli, not to go into too much detail here, but it's counterbalanced so that in some blocks, what would count as a functional deviant in one block is actually an exemplar deviant in the other. So, and I changed the key so that you have to work relationally. This is detail. I'm working on this with Tyreek Jackson, who is a PhD student and also a professor of music at St. John's University, so we're working on this together, along with Paul Sajda and my other mentors. Okay, here's some more detail. You already heard the progressions, so this more or less makes sense, but they press an A if they hear an exemplar deviant and an S if they hear a functional deviant. I'm recording EEG. I'm looking at P300 amplitudes. P300 is a ERP component, and it is associated with the oddball saliency. So by looking at the amplitude of this component, we can see how similar the oddballs are to the standards, how different they are in terms of their representation. So if a functional deviant really is more different in terms of how it is conceived or represented, we would be able to see that through the amplitude of the P300, in addition to looking at behavioral measures. Okay. So just to be clear, the hypotheses are that the improvisers should more easily detect function than exemplar, miss more of the exemplars. Function should have greater P300 amplitude. It should be easier to identify because they're used to making the exemplar shifts. Those are considered to be more the same. Whereas for a classical player, different is different. If it's different, it's different. One is not more different than the other. It's different. They're not used to making these kinds of functional substitutions. I have some pilot data I'd like to share with you. Here's an ERP from electrode CPZ. It's around here. And you can see that indeed from these 8 improvising participants, the function ERP does indeed have a greater amplitude. You can see where chord 2 comes on, that's the one that's different. And you can see that there's this P300. You might have noticed that it's a bit late. P300s can come, I've read, as late as 600 milliseconds, although that's quite late. I suspect this is because you're also getting information from the 3rd chord about the difference. The 3rd chord also helps you tell that it's different. So time locked to that, it makes sense. I'm still working on how to dissociate the contributions of each chord to the identification of the deviance. But the improvisers do indeed have a greater amplitude P300 for the function than the exemplar. It's significant at this point too. Here are some scout plots that show it indeed looks like a P300 should look in terms of the pattern of activation. We've run 2 non-improvisers, which so far aren't showing this difference, so far so good. I should mention that since running these, we slightly changed the task so that now there's only 1 button to respond instead of 2. There are reasons for that, which I could describe in questions. But so far so good. Scout plots look very similar. Okay, next steps. I would like to eventually be doing a representational similarity analysis study using fMRI data. The idea would be that you could look at lots of different progressions, each one having many different exemplars, and you could see, with more detail with fMRI, indeed, are all of these things represented in a similar way? Is there some objectness to these progressions that can be detected differently in improvisers than non-improvisers? And with fMRI, you'd be able to tell which parts of the brain contribute to those representations, which would help make a link between this kind of a description and a description of practice. Why does this help them improvise? Or why does this underlie improvisatory abilities? Just a brief note on some relevance. It shouldn't be taken for granted that there are differences between these groups. Many music psychology studies do not distinguish between different kinds of musicians. I think it may be an important latent variable that could be taken into consideration in other musical psychological studies. It's also phrasing in terms of different kinds of knowing can be connected to theories in embodied cognition. You can use this kind of analysis to look at different improvisatory practices in different times and in different parts of the world. Also in non-musical practices, it can contribute to definitions of improvisation outside of music. And similarly with creativity research, there are links there, which can be discussed at another time. But thank you very much for your attention. I think we'll have a discussion now, and thanks for your attention.
Could I ask the mentors, please, to come to the table also? Andrew's mentors are Daphna Shohamy from Psychology and Neuroscience, and Paul Sajda from Biomedical Engineering.
I'll start with a confession, which is that when Andrew came to speak with me for the first time about this program and his interests in linking neuroscience and music, I thought he absolutely confused me with someone else because I'm not scientifically interested or knowledgeable when it comes to music. And I thought I'd have really nothing to contribute, and that he just wanted to do brain imaging, and that must be the explanation. But then when I listened to Andrew describe his interests more deeply, I realized that actually he and I have a great deal in common, and that there are really important questions that are near and dear to my heart about learning and how we represent knowledge, what we remember and how we use what we remember, and that those were really important areas of overlap. And it made me realize that music, or improvisation rather than music, music as well, are a really interesting case study, an example of things we learn that we can learn in different ways. And so for me, that's been a very interesting context, and as it specifically relates to, I think, this tension that those of us who study learning in the brain think about a lot, the tension between remembering a particular event in a manner that's very accurate and complete, and between the desire to link and abstract any particular event with other events that happened before it, around it, and sort of bring the level of representation up a notch to link between episodes or memories, with one consequence of that being a form of flexibility of knowledge. And I think this tension between specificity and flexibility that we've thought a lot about in the field of learning and memory is very relevant to this question that Andrew's been exploring. So it's been educational for me. And maybe if I have time for one last comment on that, I think it's worth asking for this project and for all of these projects, what does the neuroscience side of things buy us in terms of our understanding of many of these processes? And so without going into too much detail, I was just saying that in the world of learning, the idea that there's this tension between specific episodes or kind of more abstracted forms of knowledge is exactly the sort of question where people felt or thought for a very long time that it must depend on different parts of the brain. And it was neuroscientific studies that kind of came back and said, no, actually, there are common areas of the brain that are contributing to both of them, and we can understand in more detail how those areas of the brain underlie that process and communicate. So with that, it's a little vague what I just said, but I think it's an example where neuroscientific data kind of changed our theoretical perspectives on how memory and learning are organized. And so that's just, I think, a nice example. Just inspiration.
So just to comment a little bit also on the context of this with regard to Andrew's work and some other things that I've been interested in, I think that are also highly relevant to the question of, when we do human neuroscience, what are some of the advantages of using the human subject over the monkey that you can actually put electrodes in, right? So over time, one thing that I've been particularly interested in is this idea of people have expertise, acumen, skill set that they developed over many, many years. So this is something that they've learned outside a laboratory experiment. Maybe they're a really good improviser, maybe they're an athlete, maybe they're a really good chess player. The question is, can we use those types of subjects and kind of probe how they represent and make decisions, so represent information and make decisions on tasks that are much more controlled than in the laboratory. In fact, I had done a little bit of work before Andrew came on musicians, though I'm not a musician, know very little about music. I had another smart musician that worked in my lab, but we looked at athletes, for instance. And so the idea of thinking about how we take groups of individuals that might have learned in a completely different context. One group might have spent the last 10 years of their life waking up every morning at 6 o'clock and practice for 3 to 4 hours a day, versus a bunch of graduate students we bring in the lab. And we look at how, let's say, they do a task that has some analog to the expertise group. I think one thing that we started to see, and I think that is also we're gonna see in Andrew's work as we add more modalities, is the fact that the representations that are traditionally associated with decision-making variables are expressed in different areas depending on how these individuals became expert in that particular domain. And it's not that they're expert, there's actually no difference in how they perform the task, but how they actually got that expertise that in some sense is a context for the task. So I think that that's going to be really another contribution that Andrew's work brings. I think the improvisation is really quite interesting also because there is clear this perception-action coupling that can also kind of be explored with this group of individuals. And I think we're going to hopefully use these other modalities as well as not also taking advantage of the neural data that we have. You'll see Andrew averaged or showed these ERPs, which are kind of a very classic way to look at this type of EEG data, but there are kind of additional methods that can be brought to bear these days. He mentioned representational similarity analysis, but other types of methods that can exploit and look at how things vary across time, across trial, across an experiment that might provide more insight into these questions about, somebody comes to this task, they have a different prior or background, do they learn differently doing this task? Is that expressed in how that activity changes within the experiment. So.
Do you want to respond?
Can I just make a couple
Yeah.
comments in response? One, just about what musicians can offer us in this pursuit is that there are musicians who can and cannot improvise, or at least appear to have very different practices. It's not so for something like speakers, people who speak a language. Pretty much everyone who speaks a language can improvise in the language, but in music we have this case where we can compare a bit more starkly people who can and cannot improvise. And the other is a comment about what the neuroscience brings us. So one conception of this process could be that, well, people who improvise have brain area X activated in this way, and I didn't realize it, but actually when people do behavior, A, that the same brain area is active. Therefore, these things must have something in common. And neuroscience, I suppose one way of thinking of this is could help us make a link that was unforeseen outside of this way of looking. At the same time, I feel like in order to make that kind of a link, that relies on some kind of critical interpretation of what it is that those things are. I guess it ends up being a different kind of knowledge of the phenomenon. One would be like a pragmatic knowledge, which is, okay, both activate this area of the brain. I'm not sure what it is that it is, but both activate the same area and I can manipulate them in the same way. I know that damage here will affect both. You don't ever really need to say what it is. You have some other kind of knowledge. Another is a desire for some kind of like realistic description, maybe something metaphysical of what these phenomena are, and is there something like natural about them. Different kinds of knowledge. I just thought I would mention that. I really think it takes both ways. It's something that is an active discussion to continue. It's important, this kind of a question brings that straight, to the forefront of what it means to be doing neuroscience in this case.
Yeah, thank you very much. Okay, floor is open. Yes. And then Mike.
Hi. This is fantastic work also. As a scientist and a musician, I fully support this sort of stuff. The point about expertise was something that I was sort of ruminating about all during your talk, and I sort of thinking about the U-shaped function of expertise. At the beginning, as a novice, you have very little information. Obviously, you accumulate knowledge over practice and time. But there also comes sort of this weird point in the expertise curve where too much knowledge about a topic or about some sort of domain can actually hurt you. And about the studies that some experts can actually miss certain parts of something, whereas novices can pick up on it because, again, those schematic structures aren't as integrated as they are for experts. So I wonder about something like that in relation to detecting deviance and deviancy and sort of improvisation. And maybe if you can talk about, maybe all deviations aren't necessarily detected by an expert because in their sort of schematic organization of sound and perception, it doesn't seem, as oddball as some. And so maybe if you can talk more about the mechanistic differences in experts versus non-experts and how that might sort of inform the questions that you're looking at.
Thanks very much. It's a really great question. I'll do my best to comment on it. I suppose one question is, do they have the same kind of expertise? Another question, and I guess I'm asking you questions in response. I get that is the question of this one. The other thing initially my mind goes to is the fact that both of these groups have a lot of experience, it's just different kinds of experience. So it's not that, I don't know, if one group has more exposure to the cores themselves than another. I'm not sure about that. It's an important question. In some ways, I've spoken with Nori about this a bit, and there may be a way to do it, but as of now, I'm not 100% sure how to do that. But I would say that I don't think that, and I don't know if this is what you were saying, but I don't think that improvisers should be characterized as, in some sense, having like a more flexible, not like a less realized or developed model in a way. They have lots of experience using these things. So that would be a question I have in response. But it is a challenge to know if they have the same kind of priors in this, and there's not a lot of work on improvisers, so it's difficult to know.
In the meantime, I'm looking for a difference here. If I find one, maybe that could help in teasing that aspect of it in the future.
Mike Shadlin, at the back.
If I may, just a quick question. I was
Oh.
curious if you had thought about either personality and or like prior existing differences. Particularly, I think maybe some people are have a stronger preference to certainty, to doing things that they know, to in foraging language maybe to stick with the same patch, and other people just may prefer this kind of uncertainty to go somewhere where they haven't been, and to what extent that may lead to this improviser versus classically trained and sticking with the sheet music player.
Right, indeed. So I have considered this, and my response to this is that my experiment cannot attribute causation to the training, but it can show a difference. So whether or not the difference arises because they train differently or only because they train differently, I cannot say. It's possible that there's some selection in these groups, that people who have this personality type tend to be improvisers more often than not sure. But anyway, if there is some reality to these groups, then whatever other differences we can find about them, we can start to map them together and form a more developed explanation.
Andrew, thanks so much for getting my head out of the clash and into Jerome Kern with one of your examples. And also, it's a beautiful design. I wanted to sort of like echo Daphna's question because I think it's just so general, but I'll make it a little bit more pointed for you, which is, what do you learn from the P300 that you didn't learn from the psychological testing?
Yep. It's a very good question, one that indeed I asked this morning. So I guess there are two ways that I would go about answering this. One is to say that whatever else we know about the P300, any study that works with P300s that can look at how different something is and make models of representations, I can do that too if I can use a P300. So I would argue that. The second thing is that I see it as, and this is a bit weaseling away from the question, but I think that there are other neuroscientific methods that can ask a very similar question that maybe are more. I really struggle with this because I don't understand what it would mean for the neuroscience to add something sui generis. I don't know what that would mean, and I don't have good examples and models of that in my mind. It seems that we can use neuroscience to augment our models, to add additional empirical predictions. I know that this also will happen in this part of the world, in the brain or something like that. But the content of the explanation isn't there, and I don't know what it's like when it is. And I would be very interested to get some examples from you.
Well, I agree with all those points.
Good. Thank you. Thank you so much.